Good evening, everyone, and welcome to our live coverage of the latest mission from Cape Canaveral Space Force Station. On deck, a NASA mission from their Launch Services Program with the acronym of PACE. I'm Will Robinson-Smith. I'll be providing our commentary for the duration of this coverage. We're broadcasting from the Spaceflight Now News Bureau at NASA's Kennedy Space Center. Taking a live look at Slick 40, Space Launch Complex 40 over at Cape Canaveral Space Force Station, a Falcon 9 rocket getting ready to launch. At the top, you see the symbol of the PACE mission. Just underneath that on the payload fairings is the NASA meatball. We're starting just under 2 hours from liftoff, so you know we've got a lot to talk about, and we'll be more than happy to guide you through the science, the impact, the technical aspects of all of this as we go through the next 2 hours before the planned liftoff of NASA's PACE mission. We've got the full team out to cover this launch. There's Stephen Young running the technical operations of our broadcast. Adam Bernstein out in the field getting ready to track the rocket and do some still photography as well. Our Michael Kane is also out in the field getting ready to do some launch photography this evening. If you're not already following them and like to keep up with their launch photography, here are their handles on X, formerly known as Twitter. We also have support for our launch coverage tonight from our friends Pete Carsons with Max Q Productions and Chuck Briggs as well. Both will be providing tracking views of tonight's Falcon 9 launch. And it's a busy time for SpaceX as we do see they have a Falcon 9, of course, getting ready to actually launch this evening, or I should say in the overnight hours. It'll be T0 liftoff of 1:33 a.m. on Thursday from the East Coast time zone. But also on their other pad here on Florida's Space Coast, Launch Complex 39A, see another Falcon 9 raised vertically just a few hours ago. This particular Falcon 9 rocket has another very important payload inside for NASA, though it is not formally a NASA forward mission. This is a Falcon 9 rocket with Intuitive Machines Nova C lander. Similar to the Peregrine Mission 1 launch that we saw earlier this year aboard a United Launch Alliance Vulcan rocket, the IM-1 mission is part of NASA's Commercial Lunar Payload Services, or CLPS, program. What that means is NASA has a suite of scientific payloads on board the Nova C lander, but it is just one of a number of customers that have their hopes pinned on this lander being able to safely reach the moon and become the first commercial lander to have a soft touchdown. So that mission getting ready to launch no earlier than Valentine's Day of next week, coming up on the 14th. Just shy of 1 a.m. Eastern Standard Time. Of course, we'll have much more on the IM-1 mission coming up as we get closer to that liftoff. Reason we're bringing you this view right now, one, because the rocket's actually on the pad. The reason it's on the pad is because the spacecraft will be going through a wet dress rehearsal tomorrow. Unlike most payloads on board a Falcon 9 rocket with the payloads fairings buttoned up at the top, the IM-1 Nova C lander has to fuel as close as possible to liftoff in order to meet the criteria for its flight profile. So they'll be testing that procedure in full. They've done a number of tests with just the transporter erector or the strongback leading up to this wet dress rehearsal. SpaceX has added this new capability to support the IM-1 mission, an operation that can only be done from here at Launch Complex 39A. So we'll keep you posted on the progress of that. But of course, tonight, as we stand at T-minus 1 hour, 55 minutes, 50 seconds and counting, we are primarily focused on this Falcon 9 getting ready to launch the PACE mission. To get an idea of what's inside those payload fairings on the Falcon 9 rocket, here's a rendering of the spacecraft. By the way, PACE stands for Plankton, Aerosol, Cloud, Ocean Ecosystem. So you got the E from ecosystem. A little bit of a condensed acronym. The spacecraft is 1.5 by 1.5 by 3.2 meters. Or if you'd like to use something other than the metric system, it's 4.9 by 4.9 by 10.5 feet to give you a sense of its scale. This will be SpaceX's 8th launch supporting missions for NASA's Launch Services Program, which is based right here at the Kennedy Space Center. It's also the latest in a long line of Earth-observing spacecraft. This one is designed to provide rich data on our oceans and atmosphere. And we're going to be digging into the details of the PACE spacecraft and the mission over the next couple of hours. Don't you worry about that. But let's talk about the launch timeline. Currently, SpaceX targeting that T0 liftoff, as I mentioned, at 1:33 a.m. Eastern Standard Time. For our viewers joining from around the world, that's 06:33 UTC. And of course, if you'd like to support our coverage of the space program, there's a quick and easy way to do that. For the more than 1,200 of you that are joining us live, if you just hit the like button. If you're not already subscribed to Spaceflight Now, I'd love it if you subscribe to the channel. It's also free to do that as well. And tap that bell icon when you do, so you get notifications for when our streams go live. You don't miss any of those, as well as when we post new videos. Sharing the stream also helps more folks find our live coverage as we continue to step through the count. Coming up at T-minus 1 hour, 53 minutes, 33 seconds and counting. In addition to our wonderful viewers like you joining us for our live coverage, we are powered by channel membership, which comes with a number of perks, including access to member-only videos here on YouTube, the ability to watch all of our Cape launch coverage in 4K, and of course discounts at our online shop, which is shop.spaceflightnow.com. So to all of our wonderful channel members joining us this evening, thanks for being on board. Really appreciate your support. Glad to have you with us tonight. Speaking of folks in the live chat, I'd be remiss if we didn't mention all of our wonderful moderators that help keep the live chat kosher and allow for a good, healthy environment and discussion of this mission, as well as anything else really going on with your life that is appropriate for the chat. So thanks to the mods for helping out. I see Michael Kane helping out with the moderation tonight as well. Last but not least, you can also participate in the show by using the YouTube Super Chat feature. You're not only helping to support our ongoing efforts to continuously upgrade our hardware to improve the quality of these live streams, but you also give us some great points to talk about. We'll do our best to incorporate those comments and questions if they're appropriate to be read on our broadcast as well. We'll also be keeping an eye out for some good member comments popping up in the live chat. We'll do our best to keep an eye on that as we continue to step through the count. Now T-minus 1 hour, 51 minutes, 45 seconds and counting. Less than an hour 20 away from the point at which the launch director will give their go for the start of propellant load. Because this is a NASA mission, we should also be getting some clean mission audio loops of the countdown in progress. Of course, as soon as those become available, we will bring that to you as an element of our broadcast. That said, when we reach that point, you may hear me pause periodically so that I'm not talking over those updates and we can all hear the relevant callouts. SpaceX is running its countdown from its Hangar X site here at NASA's Kennedy Space Center. It's the facility where they refurbish Falcon boosters and prepare them for future flights, as is the case with the booster you see here on your screen. NASA is also, of course, alongside SpaceX inside Hangar X, as they are with crewed missions to the space station. SpaceX also has support for this launch in part from the control room at their headquarters in Hawthorne, California. Again, tonight's launch targeting that T0 liftoff at 1:33 a.m. Eastern, 06:33 UTC. Because of the nature of this mission, and we'll discuss this in more detail as to why, but they only have a brief 90-second window for this launch. If needed, SpaceX and NASA do have the ability to pivot to a backup window tomorrow if need be. We're now T-minus 1 hour, 48 minutes, 9 seconds and counting. Of course, you've been following the progress of the PACE mission. You know that one of the big stories leading up to the launch attempt this week has been weather. Strong winds have scuttled opportunities to launch on both Tuesday morning and this morning. Taking a look at the flagpole here at the press site. See the American flag still waving pretty steadily there, although I will tell you from stepping out and being out around the press site earlier today, the winds are much calmer than they have been on the Space Coast over the last 2 days. So things much more in a good order for a potential launch tonight. Coming into this launch opportunity for a liftoff Thursday morning, meteorologists with the 45th Weather Squadron forecast 95% favorable weather at liftoff. It's a big swing from the 40 and 50% odds in the previous 2 attempts. So from a weather perspective, we are trending in a much, much better direction, which is certainly good news for those of us wanting to see a launch tonight. Now T-minus 1 hour, 46 minutes, 41 seconds and counting. Because we've got a bit of time and a lot to talk about, we're actually going to hit the trajectory twice in our broadcast, once this hour, and then we'll come back to it again as we cross into the final hour before the planned liftoff. We actually have a couple of trajectory maps to show the dynamic nature of this launch. Very much appreciate both Stephen and Adam for working on these in the run-up to the launch attempts. Let's go ahead and show their good work and walk you through a unique trajectory for this launch. Of course, the Falcon 9 lifting off from SpaceX's workhorse pad at Slick 40 over Cape Canaveral Space Force Station. This time, though, Falcon 9 is going to be flying in a southern trajectory towards the Caribbean, as you see along the coast of Florida. But because PACE, the spacecraft, is going into a sun-synchronous polar orbit, Falcon 9's second stage is going to be performing a bit of a dogleg maneuver that you see and pass over Cuba. Before that flyover, though, the fairing halves will jettison about 4 minutes into flight. SpaceX will use one of its 2 East Coast recovery ships to scoop up the fairing halves. Tonight on deck, they're using Bob. It and the other recovery vessel, Doug, of course, were named after former NASA astronauts Bob Behnken and Doug Hurley, the duo that were the first of the commercial crew ever to fly a SpaceX Dragon spacecraft up to the space station on the Demo 2 mission back on May 30th, 2020. Now, before we get into the booster portion of the recovery effort, here's an image from SpaceX of a previous fairing half splashing down in the ocean underneath its parachutes. SpaceX touts roughly $6 million in savings per recovery, though they didn't specify if that savings was based explicitly on the recovering of a single fairing half or for the pair of them together. Here you can see a sunset image of a fairing half being brought aboard one of SpaceX's recovery vessels. This was taken last year. The one being hoisted was completing its 13th flight to date. Earlier today, actually, we got a nice update on the fairing recoveries, courtesy of SpaceX's Vice President of Falcon Launch Vehicles, John Edwards. In response to a question on X, formerly known as Twitter, Edwards said that the current fairing half flight leader has actually flown 15 times and is getting ready for its 16th flight coming up in March. They also have a fairing half that has flown 14 times, another one that has flown 13 times at this point. Edwards says that that 13th flight fairing half is actually going to be used on the Starlink 7-13 mission. That's launching from Vandenberg Space Force Base currently no earlier than Thursday afternoon following a scrub late last night. I know a number of you were with us as we were counting down that mission. Got into that final minute before they called the game, and so now that is standing down until we get on the other side of the PACE launch. SpaceX is using new fairings, though, on this particular mission. It's a lovely photo of the PACE spacecraft at sunset here. To date, all NASA Launch Service Program flights have featured brand new payload fairings. During a press conference that we had earlier this week talking about the mission, we heard from Tim Dunn, who's with NASA LSP, who mentioned that they are evaluating using flight-proven fairings on future NASA LSP missions. However, he said that's about a year and a half or 2 years away from actually happening. So expect to see all of the NASA missions with as shiny of new payload fairings as the fairings get. Rounding out our trajectory talk here, let's go to the other map from Stephen and Adam. Of course, the other piece is the booster landing. Now, following stage separation, the particular booster supporting this mission, tail number B1081, is going to perform a flip maneuver and return for a landing back at landing zone 1 at the Cape. Speaking of recoveries, let's go ahead and pull up this video here. It's a short clip from earlier today. You see a Crew Dragon spacecraft with the Axiom lettering on it. This was the Crew Dragon Freedom that undocked from the space station just this morning. The 4 astronauts of the AX-3 private astronaut mission, they are now making a roughly 47-hour-long journey back to Earth. Of course, as been with the case of all operations this week involving launches and landings and capsule recoveries, teams with Axiom, SpaceX, and NASA keeping a close eye on weather conditions for that recovery operation as well. Splashdown currently set for right about 8:30 p.m. Eastern off the coast of Florida. We're now T-minus 1 hour, 14 or 40 minutes, 11 seconds and counting. I'm going to take a quick peek at the live chat. We've got a few folks that have shown their support and want to acknowledge and thank them, as we are powered by all of you helping to support us in what we do here at Spaceflight Now. Thanks to one of our channel members, Josh King. Glad to have you with us this evening for a $10 super chat. Question coming in before we actually got to the trajectory. So question asked and answered if the booster is going to return for a landing back at the Cape. As we all just saw, the answer to that is a resounding yes. So if you yourself or you have some friends or family that are on Florida Space Coast ready to watch the launch with their own eyes, or are in the area of Central Florida, you might want to let them know that they could very well likely hear that sonic boom as the booster is coming back in and coming in for that landing. RTLS, return to landing site. Want to go with the acronym version of that. Our thanks to another one of our wonderful channel members, Callistia Lee, joining us again this evening with a bit of generosity, gifting 10 Spaceflight Now memberships. Thank you so much, Callistia. And if you were one of those 10 that got one of those 10 memberships, be sure to thank her in the live chat if you haven't already, and enjoy the perks of channel membership. And lastly, for now, I want to thank Rosie Wren, the queen of YouTube forever, for being a channel member at the PAL leader level for the past 6 months. Thanks for being with us, Rosie, who says, awesome live stream. Thank you for the kind words of affirmation. Let's go ahead and keep this stream right on rolling. We're T-minus 1 hour, 38 minutes, 22 seconds and counting. Returning to the PACE mission itself, as I mentioned, it will be launching into a sun-synchronous polar orbit. We're going to come back to that sun-synchronous part of the equation in just a bit, but let's focus on the polar orbit piece for just a moment. As eagle-eyed launch viewers may have noticed, a lot of these polar trajectory missions historically have been happening from the west coast, from Vandenberg Space Force Base. There were some polar missions launched from the Cape leading up to 1960, but that year there was a failed launch during which rocket debris fell and hit a cow in Cuba, as many of you in the live chat and watching us right now may have either read about or may have been alive for. Created some large protests in Havana. Now, earlier this week on Monday, Tim Dunn, who is the Senior Launch Director for NASA's Launch Services Program, also the launch director for this particular PACE mission, he explained what changed after the Cuba incident. We're just queuing up to make sure everything is working on a technical front. As I was mentioning, here is Tim Dunn talking about the shift away and now the shift back to Florida-based polar launches.
At that point, we as a government decided, let's just take all of our polar launch missions to the west, and we've successfully launched into the polar orbit hundreds of times since the 60s from Vandenberg Space Force Base in California. But along comes SpaceX a handful of years ago with autonomous flight safety system and the ability to either bring the first stage booster back to land here at the Cape or land it on a drone ship offshore. And by the combination of those two things, we were able to then do all of the calculations to protect the public both here in the U.S. as well as our international neighbors in the Caribbean and especially in Cuba, and to get the numbers right where we can now successfully do that. And as I mentioned, SpaceX, this will be their 12th launch into this specific polar orbit from the Cape. So there's no question about that this is a well-exercised process that we're doing. It's just interesting for the history of why we haven't done it in so long as a nation until a few years ago.
Again, that was Tim Dunn from NASA LSP. As he mentioned, SpaceX has completed 11 other polar orbit launches from Florida since it received the go-ahead to do so, starting back in 2020. In fact, what you're seeing here on your screen is a condensed version of what in real time took about 8 minutes from liftoff to booster landing. As it so happens, this mission was also an Earth-observing satellite that launched. SIOCOM-1B was launched alongside 2 other rideshare satellites. See the hypersonic grid fins that are deploying as the booster making its way back down towards landing zone 1 here in this replay video. As things stand right now, SpaceX has completed 295 launches of its Falcon 9 rocket and 269 booster landings to date. There have also been 35 landings so far at landing zone 1. You stack that together with landing zone 2, there have been 44 land landings in Florida up to this point. Looking to add one more to both of those stats with the completion of the PACE mission, the secondary part of the booster recovery, coming up later on this morning. We're now just crossing over midnight here on the East Coast. So all of you up and down the eastern seaboard, good morning. There we go with the completion of that landing is basically what we're looking to see from this booster coming up tonight. It's going to be making its 4th flight and, if all goes well, its 4th landing. T-minus 1 hour, 31 minutes, 10 seconds and counting. What you're looking at here now is a rendering from NASA showing PACE's sun synchronous orbit. Mentioned I would get back to this, and here we are now. What that means is that it will always maintain the same position in comparison to the sun. So as you're seeing this rendering, it crosses the Earth's equator at the same time, local time, with each orbit. It's offset by the sun by about an hour, so if you imagine that yellow block you see there around the globe represents the direct sunlight over the noontime space. You see PACE is about an hour behind that, hitting the 1 o'clock marker. NASA says they planned for that to reduce glare off the ocean's surface while also getting as much sunlight on the body of water being observed by PACE as possible. Now, part of achieving that orbit is also the reason why we're seeing the launch of the PACE spacecraft, or the hopeful launch, at 1:33 a.m. Eastern Time. PACE will launch directly into its permanent orbit, which is also why they have effectively an instantaneous launch window as well, lasting just 90 seconds. And the wiggle room within that small amount of time, which is, barely we consider wiggle room, but they'll be using mostly the back 45 in case they need to shift around at all slightly. Now T-minus 1 hour, 29 minutes, 37 seconds and counting to that planned liftoff. We're also about 50 or so minutes away from the point at which the launch director, Tim Dunn, will make a call about the start of fueling. Let's take a quick peek at the live chat, see what member comments there are. If there's some folks to thank for their support, which it does appear to be. I am Letta, one of our wonderful channel members, with a $2 super chat. Very sweet words. The best commentary and chat buddies. Thanks all. Good to have you this evening, Letta, and hope everyone is having some good chat in the live chat. Our thanks also to Joseph Dombrowski with a $5 super chat, asking if there's a visibility map for this launch. We will return to the trajectory maps that Adam and Stephen have wonderfully prepared in just a little while. That'll give you a sense of the flight path of the rocket. It'll be mostly visible for those in the southern Florida area. And of course, if you are in Cuba or in the Caribbean, you might be able to spot it as well. That's second stage. Seeing a little venting there from the strong back as they're not yet quite ready to start fueling just yet, but this is about the time when we would start seeing that little bit of venting, so a good indication that we are, generally speaking, on track for the start of fueling coming up in just a little while. We'll go over the launch countdown timeline when we get a little bit closer to it being more relevant. But it'll start, of course, with the call on the start of fueling by the launch director at T-minus 38 minutes. So we have a little bit of time before we need to really start dialing into the fueling milestones. Fortunately, we do have that time, so we can continue learning and talking about all things PACE, which is the focus, of course, of tonight's mission. We're now T-minus 1 hour, 26 minutes, 27 seconds and counting. Now, prior to its encapsulation in the Falcon 9 payload fairings, we actually got an opportunity to see the PACE spacecraft over inside the clean room at Astrotech in Titusville. It was a very tightly controlled situation, so we were gowned up in what are called the bunny suits, which you'll see in just a moment, with a full mock-up. And you'll see Adam, I believe he makes an appearance in the background of one of these shots. You can see him taking some photos and video of the PACE spacecraft while we were conducting this interview. So be sure to keep an eye out for him in the background. But while we were inside the clean room, we spoke with Brian Kenz, who is the deputy project scientist in the atmosphere portion of this PACE spacecraft. We talked about the three primary scientific instruments that make up PACE. So let's go ahead and take a look. This is part of our conversation with Brian Kenz.
All the way at the top is the ocean color instrument. It's the main instrument on the mission. It has a 2,500 kilometer swath and sees from the deep ultraviolet all the way into the infrared. And so we'll see the whole globe in full color in all its glory every day. And then the next instrument down with the black baffle is called the HARP-2 instrument. It's an acronym is the Hyperangular Rainbow Polarimeter. So that's because it has lots and lots of viewing angles, and so you'll be able to see the cloud bows. And the shape of a cloud bow tells you what size droplets are in clouds. The next instrument down is another polarimeter. It's SPEX-1, the spectropolarimeter for planetary exploration. This is from Esron in the Netherlands. Originally, they were planning on flying an instrument like this to Mars many years ago, but now it's going to be flying and looking at the Earth. And it looks from the ultraviolet also into the near infrared. And so the two polarimeters are very complementary to the main spectrometer instrument and provide the ability to characterize particles in a way that you can't from just looking at the spectrum.
And our thanks again to Brian Kens for his time in the clean room. And if you haven't already, we've got a video dedicated specifically to the science of the PACE mission up on our YouTube channel. So if at any point in the next little under hour and a half now, if you want to put this video on mute and bring that video up in a separate box and watch a more concentrated version of the longer conversation that we'll be having leading up to this mission launch, you can go ahead and do that or just revisit it at any time. We're now T-minus 1 hour, 23 minutes, 13 seconds and counting to the planned launch of NASA's PACE mission. No, T-minus 1 hour, 19 minutes, 20 seconds and counting, away from the planned launch of NASA's PACE spacecraft. Taking a look at the live chat. I have a super chat here from Jeremy Ladd, $5. Thank you so much, Jeremy. Says about to head to the roof to make more pictures of the launch. Tagged you on X and some of the stuff, so please check it out. I was just looking over at X, and I have not seen those yet, but be sure to keep an eye out. Thanks for thinking of us and for taking some pictures. Hopefully those come through. Look forward to seeing them if they do. T-minus 1 hour, 17 minutes, 57 seconds and counting. Heard a little bit about the instruments on board the PACE spacecraft from one of the project scientists, but let's drill into them just a little bit more while we have the time. Bringing up this rendering here. This is a rendering from NASA of the primary instrument they heard at the very top of the PACE spacecraft. This, of course, without the protective covering. This is the Ocean Color Instrument, or OCI. It's an optical spectrometer that measures the properties of light via the electromagnetic spectrum. Simply put, this will observe the color of the oceans, sufficiently large bodies of water, and it will determine the species of phytoplankton within them. We'll circle back to the phytoplankton bit in just a little. At the bottom of this image, though, you can see that cross-track rotating telescope. You can see that with a green arrow. It will continuously rotate 360 degrees once this instrument is configured and it's on orbit. You can see that human-like figure standing for some general scale. You see that sort of mustardy colored arrow near the bottom left of this image here, labeled the fiber-coupled multiband filter spectrograph. It's what allows the OCI to make observations in the near-infrared to shortwave infrared. Moving along for another vantage point here on this particular instrument, it's also able to make observations in the ranges of ultraviolet to visible light and from visible to near-infrared. To do that, it uses what are called split grading hyperspectral spectrographs. It's a mouthful, I know. But you can see those with the yellow arrow at the bottom of this image. This flight instrument was built at NASA's Goddard Space Flight Center in Maryland. Getting some live views from our friend Chuck Briggs here. Excellent view of the Falcon 9 rocket.
All the way at the top is the Ocean Color Instrument. It's the main instrument on the mission. It has a 2,500 kilometer swath.
Apologies for that little audio snafu. We worked through that user error glitch on my end of that. Coming back to the PACE spacecraft, as part of our visit to the Astrotech facilities in Titusville, we had the opportunity to speak with the main project scientist for the PACE mission. Jeremy Wardell is also an oceanographer in the Ocean Ecology Laboratory at Goddard Space Flight Center. We spoke with him about the advances that the spacecraft will have on our understanding of the planet. This is part of our conversation with Jeremy Wardell.
Where we are today is a box of crayons, because we measure color. That's what we're doing. That is maybe 8 crayons in that box. And what we're delivering is the box of 128 crayons. So all of these additional colors of the spectrum that will allow us to see things we can't currently see. On top of that, we have instrumentation that basically operates like you put polarized sunglasses. And so, you know, if you own polarized sunglasses and you're looking at the water, you can see how the texture and the color changes. And that information is novel too. And we view at different angles, and all of the instruments play off of each other. So the long and short of it is this combination of instruments is unlike any that NASA has or any of our international US partners have. And there's no plans for them as well. And this new information is going to create this renaissance in how we understand different aspects of our home planet. So much so that one of the biggest hurdles the science community is going to face is how do you take this sheer volume and do something with it? Like, it's scary. It is so much more new information that we have.
And our thanks to Jeremy Wardell for that chat we had with him and giving us some insight into the PACE mission. Our T-minus 1 hour, 11 minutes, 28 seconds and counting. Coming up on the 1 hour mark in just a little over 10 minutes from now. Taking a quick peek at the live chat. We have a super chat here from one of our channel members, Josh King, for $10. Thank you so much, Josh. Really appreciate that. Who asks, does Crew 8 have a launch date yet? And I believe Michael Kane jumped in to answer that in the live chat as well, noting that currently they are targeting no earlier than February 22nd for that early morning launch. However, that is contingent on what's happening over at 39A currently, as SpaceX does need to launch the Intuitive Machines IM-1 mission, as that mission does have to go off that particular pad. Thank you, Stephen. Reason being that the IM-1 Nova C lander needs to be fueled as close as possible to liftoff. In fact, they're doing a wet dress rehearsal of that operation tomorrow, where they will go through the process of fueling the spacecraft via the strongback there. Which uses methane as well as liquid oxygen. This is a new capability that SpaceX added to Launch Complex 39A on behalf of their Intuitive Machines customer. Of course, this is just the first Nova C lander set to launch this year. Intuitive Machines does have plans to launch at least one more time this year. So quite a busy year for moon-bound missions. Of course, we already had the Peregrine Mission 1 launch attempt to the moon that unfortunately had a less than ideal ending. IM-1 is next on deck. As mentioned, there's expected to be another Intuitive Machines launch later this year, in addition to Firefly launching its Blue Ghost lunar lander. And possibly at the end of the year, we'll see Astrobotic back in action. They were the company behind the Peregrine lander. They're hopefully going to launch their Griffin lander with NASA's very important and very expensive Viper rover on board, which will launch to the moon's south pole. So lots in store for the moon, lots to keep track of. You sure bet we'll be covering it all. from tip to tail. We're now T-minus 1 hour, 8 minutes, 33 seconds and counting. Really appreciate the more than 2,000 of you that are joining us live. If you haven't already, there's a great way to help support what we do here just by clicking the like button. That'll go ways to helping the YouTube algorithm do its thing and bring this live coverage to more people. I want to thank a few more folks for their support this evening. I want to welcome Stephen Strickland to channel membership at the pad leader level. Welcome aboard, Stephen. Really glad to have you with us. And one of our other wonderful channel members, Norman Reitzel, has been a member since the CompuServe days. Throwing it way back. Glad you're still with us, Norman. T-minus 1 hour, 6 minutes, 57 seconds and counting. Let's move on back to the PACE spacecraft and talk about the other two scientific instruments on board. Both of them are polarimeters. First up is the Hyperangular Rainbow Polarimeter, number 2, or HARP-2. Like the OCI, this also has a fairly wide field of view at 94 degrees cross track and plus or minus 57 degrees along the flight path track. If you want to put that another way or think about it in a different scope, this particular instrument, weighing at 21 pounds, can survey the globe in just 2 days with a resolution of 1.62 miles or 2.6 kilometers. It was designed and built by the University of Maryland, Baltimore County's Earth and Space Institute. The university also, in fact, built 2 prior versions of this instrument. There was an aircraft version and a 3U CubeSat version, the latter of which launched from the space station back in 2020. Rounding out the scientific instruments on board, this is the Spectropolarimeter for Planetary Exploration, simplified to SPEX-1. This was another multi-angle polarimeter, but this one was designed and built through a collaboration between Netherlands Institute for Space Research, or SRAN is the acronym for that, and Airbus Defence and Space Netherlands. The image you're seeing here on your screen is of it when it was in SRAN's clean room in the Netherlands. Now, according to NASA, this particular instrument will measure, quote, the degree of linear polarization and the angle of linear polarization of sunlight that's reflected from the Earth's atmosphere, land surface, and the ocean. In other words, this tool will be key in helping to better characterize aerosols in the atmosphere. Aerosols, of course, are small solid or liquid particles that can interact with solar radiation and affect climate change, something that, of course, NASA and its partners around the world are eager to get more robust data about. T-minus 1 hour, 3 minutes, 47 seconds and counting. So we continue to progress toward the planned liftoff of the PACE mission early this morning. Let's talk about the workhorse vehicle from SpaceX that's going to be launching this operation. Of course, the Falcon 9. This rocket stands a tall 70 meters or 229 feet, has diameter of 3.66 meters or 12 feet. Most of that, of course, made up by the first stage bottom 2/3. This particular first stage booster, tail number 1081, has flown 3 times before. I'm going to come back to its booster history in just a little bit. At the base of the first stage are 9 Merlin 1D engines, which burn rocket-grade kerosene and liquid oxygen, which produce 1.7 million pounds of thrust. Around the engine compartment are the black carbon fiber landing legs. They'll be used to land the first stage back at landing zone 1. Above the first stage is the inner stage. It's a composite structure consisting of an aluminum honeycomb core surrounded by carbon fiber. In the image there on the right-hand side of your screen, you can see those deployable hypersonic grid fins. These titanium winglets provide steering and stability for the Falcon 9 as it comes back through the atmosphere tail first like a big old dart. At the top of the inner stage are 3 mechanical latches that attach to the second stage. First stage main engine cutoff. High pressure helium is used to release those latches. 4 pneumatic pushers ensure a clean separation. Second stage engine nozzle also housed safely inside the inner stage adapter until stage separation. Speaking of that second stage, the upper stage of the Falcon 9 is powered by a single modified Merlin engine, known as a Merlin vacuum engine or an MVAC engine. It's equipped with a large nozzle optimized for burns in the vacuum of space, and it produces more than 200,000 pounds of thrust. On this particular mission, it will be fired once to place the PACE spacecraft into its intended orbit. The MVAC engine burns the same propellant mix, kerosene and liquid oxygen, same as the first stage. And it will ignite a second time after the deployment of PACE, less than 13 minutes after liftoff. That second burn is a deorbit burn that will drive the upper stage back into the atmosphere where it will burn up, helping to eliminate the risk of any unnecessary space debris on this mission. And finally, up at the top are the payload fairings containing the PACE spacecraft. Payload fairing is made up of a carbon composite material, 13.1 meters or 43 feet tall, 5.2 meters or 17.1 feet in diameter. As previously mentioned, the 2 halves of the payload fairing will be recovered a little further downrange from the point of separation, stage separation that is. They will gently splash down under parachutes, and tonight the recovery vessel Bob is going to be scooping them out of the Atlantic and bring them back to Port Canaveral, where SpaceX will recover them on land and turn them around for refurbishment and reuse. And with that, I want to let you know that the Brevard Emergency Management Office has activated their launch operations team in support of the Falcon 9 launch for the PACE mission. Another good sign that things are in fact on track. And as we are now, T-minus 1 hour and counting to the planned launch of the PACE mission for NASA's Launch Services Program. As we are coming into a brand new hour and we'll hopefully be welcoming a whole bunch more folks, let's go ahead and pause, reset, and welcome in people if they're just now joining us. So, if you are popping in now for the first time, good evening, or good morning, depending on where in the world you are joining us from. You are joining us with our live coverage in progress for the launch of NASA's PACE spacecraft. It's just the latest mission from the busy Cape Canaveral Space Force Station here in Florida. I'm Will Robinson Smith, been providing our commentary and will continue to do so for the duration of this coverage. We're broadcasting from the Spaceflight Now News Bureau here at NASA's Kennedy Space Center. Got the full team out this evening. Stephen Young running the technical operations of our broadcast. Adam Bernstein and Michael Kane are busy with launch photography, and Adam is also doing some tracking tonight. If you'd like to follow them on X to see their photos from tonight's mission and many more coming up. These are their handles. You've got Adam Bernstein at ABurn NYC, Michael Kane at MD Kane Jr. And if you'd like to give me a follow, I'm also on X at W_Robinson Smith. We also have tracking support from our friends Pete Karstens at Max Q Productions and Chuck Briggs. In fact, this view comes to us from Chuck Briggs' tracking camera. This is SpaceX's Falcon 9 rocket sitting at the heart of Space Launch Complex 40, Slick 40, where in T-minus 57 minutes, 57 seconds and counting, SpaceX will attempt to launch NASA's PACE spacecraft. That acronym, in case you forgot it from earlier in the broadcast, stands for Plankton, Aerosol, Cloud, Ocean Ecosystem. This is a rendering of what the spacecraft will look like on orbit. It's 4.9 by 4.9 by 10.5 feet, or if you prefer the metric system, 1.5 by a 1.5 by 3.2 meters. This is set to be SpaceX's 8th launch for NASA's Launch Services Program, based here at the Kennedy Space Center. SpaceX and NASA are counting down to a T0 liftoff time of 1:33 a.m. Eastern Standard Time. That's 06:33 UTC. Your team. T-minus 54 minutes, 25 seconds and counting. As we are now within the final hour for the countdown, let's go ahead and step through the countdown timeline, shall we? First milestone coming up at T-minus 38 minutes. We'll hear the results of the go-no-go poll from the launch director. Because this is a NASA mission, we should be getting clean audio from the loops from this mission. We will be piping that in as soon as that becomes available. If that go-ahead is given, propellant load will start at T-minus 35 minutes. Begins with both rocket-grade kerosene, or RP-1, being loaded onto both the first and the second stages of the Falcon 9 rocket. Also, liquid oxygen will be loaded on board the first stage. T-minus 30 minutes. Cryogenic helium will be loaded on board the first stage, the pressure vessels there. That same process of helium being loaded onto the Falcon 9 will happen for the second stage at T-minus 26 minutes. T-minus 23 minutes, the second stage kerosene tank should be fully loaded. At T-minus 20 minutes and 50 seconds, the strong back chill down process begins. It's a very striking visual sign that fueling is progressing on track. See quite a bit of venting from the strong back. Happens as the feed lines are being chilled, setting up for T-minus 16 minutes when the liquid oxygen loading begins on board the Falcon 9's second stage. And at T-minus 7 minutes, the chill down of the 9 Merlin engines gets underway. It involves flowing a small amount of liquid oxygen through the plumbing and the turbo pumps. It protects the engines from the risk of thermal shock and damage during the startup sequence. About 6 minutes out, we'll see the first stage kerosene tank should be full. T-minus 4.5 minutes, we'll see the strong back retract begin away from the Falcon 9 rocket. It starts with the clamp arms underneath the payload fairings opening up, and then the transporter erector, or the strong back, however you want to term it, will recline about 1.5 degrees away from the Falcon 9, just a slight lean back, and it stays there until liftoff. At that point, the strong back will pull back in a much more rapid fashion to clear the way for the vertical climb of the Falcon 9. 3 minutes out, the first stage liquid oxygen loading will be complete. 2 minutes out, LOX load should be complete on the second stage as well. At that point, the Falcon 9 is fully loaded with 1 million pounds of propellant. In the final 60 seconds, control of the countdown is handed over from the ground sequencer to the Falcon 9's onboard flight computers. The launch director gives their go for launch at T-minus 45 seconds. The engine ignition command is issued at T-minus 3 seconds. Then, of course, if all 9 engines ignite and are healthy, the flight computer will give the command for the hold-down clamps to release the vehicle for T0 liftoff. Coming up at 1:33 a.m. Eastern Standard Time, 06:33 UTC. That's now just shy of 51 minutes away. Taking a look at one more graphic here before we peel away from our slide deck. This is a bar chart of SpaceX Falcon launches to date, both of Falcon 9 and Falcon Heavy missions. SpaceX managed to launch 10 times last month. This set to be launch number 11 if they're able to launch the Falcon 9 rocket on the PACE mission tonight. Now T-minus 50 minutes. 23 seconds and counting. We're now T-minus 48 minutes, 35 seconds and counting. About 10 minutes away from the point in which the launch director, Tim Dunn, will make the call on the start of propellant load for the Falcon 9 rocket, supporting the PACE spacecraft. PACE's mission, of course, is part of NASA's Science Mission Directorate portfolio. In the run-up to this launch, we also had the chance to talk with the Associate Administrator of SMD about this mission. Dr. Nicola Fox described how PACE fits into the overall idea of the Science Mission Directorate. Here is part of our conversation.
In SMD of like the search for life elsewhere. And, so we're obviously excited by bringing the samples back from Bennu, going off and getting ready to launch Europa Clipper later this year to explore the ocean world of Europa. But PACE allows us to explore the ocean world here. And if you think that we're the only planet right now that we know that sustains life, and all of the life that we have here on Earth started in the oceans. And so by studying the oceans and studying what's in there and kind of learning about that, I actually think it's a really key part of understanding how we would ever go about finding life or signatures of life on other worlds. And so, PACE really fits right into the central theme. Of course, it's helping us here on Earth. It's helping us, make sure that we have better food sources, better security, better air quality. It's making sure that we understand all of that, doing all that really cutting edge science to allow people and decision makers to actually have the best science. So everything that I really think that PACE is just a jewel. It's even more than you think it is.
And our thanks to Dr. Fox for spending part of her time talking with us about the PACE mission and how it fits into SMD. Now T-minus 46 minutes, 21 seconds and counting. We are T-minus 45 minutes, 18 seconds and counting. We are now less than 7 minutes away from the point at which the launch director would make the call on the start of propellant load, and as promised, said for those who weren't around last time that we'd come back to the trajectory, and I am nothing if not a man of my word. So let's talk about where this Falcon 9 is going once it leaves the pad. Before we get rolling though, if you haven't already, first off, thank you to the more than 2,300 of you who are watching live. Be sure to click the like button to allow more folks to find this live coverage as we come on into the final 40 minutes before the planned liftoff of the Falcon 9 rocket. So trajectory again, for those who may have missed it last time or just want a nice little refresh. Falcon 9 going to be launching off Pad 40 over at Cape Canaveral Space Force Station, and it's flying in a southern trajectory towards the Caribbean. Upper stage will continue on with the PACE spacecraft. Because PACE is going into a sun-synchronous polar orbit, the Falcon 9 second stage is going to be performing that dogleg maneuver, passing over Cuba. Before it does make that fly over, the Bering halves will jettison about 4 minutes into flight. SpaceX is using one of its 2 East Coast recovery vessels to scoop up the fairing halves. Tonight on deck is Bob. It and the other recovery vessel, Doug, named after the duo of the Demo 2 mission, which launched the commercial crew era into the human part of that venture back on May 30th of 2020. This is what the fairing halves look like as they're coming down for a splashdown in the Atlantic or the Pacific. SpaceX saves about $6 million per recovery, as they are, like the Falcon 9 first stage boosters, working to reuse them as often as possible. This is what it looks like when they're being brought aboard one of those recovery vessels. This one in the picture here being done for the 13th time. In response to a question on X earlier today, we did get a bit of an update on sort of where things stand with the fairing half flight leaders. Currently, according to John Edwards, who is SpaceX's vice president of Falcon launch vehicles, there's a fairing half that has 15 flights under its belt, getting ready to launch for a 16th time in March. They also have fairing halves that have flown 14 times, another one 13, and that 13th flown fairing half is getting ready to get back into service with the Starlink, aptly, 7-13 mission. That's set to launch from Vandenberg Space Force Base no earlier than this afternoon, following a scrub the previous night. However, the fairing halves on board this particular mission, which you see the mission patch there for the PACE mission just above the NASA meatball logo. These are new fairing halves. During a press conference, Tim Dunn, who is the launch director for this mission, said they are evaluating using flight-proven fairing halves on future launch services program missions. At this point in time, they have not gone through enough data and conversations to make that go ahead. But Dunn says that they expect to introduce flight-proven fairing halves on NASA missions in about 1.5 years or 2 years away. Coming back to the trajectory itself, talk about the booster recovery. An important secondary piece of this mission for NASA and SpaceX, of course. The booster is going to be performing a flip maneuver, tail number 1081, coming back for landing at landing zone 1. We're now T-minus 40 minutes, 31 seconds and counting. Just about 2.5 minutes away from the point at which the launch director, Tim Dunn, is going to be making that call on the start of propellant load, which should begin in about 5 minutes if all is ready to go ahead for that. We're now T-minus 39 minutes, 4 seconds and counting. Minute away from that call on the start of prop load. I want to thank a couple more folks for their support as we approach that milestone. Jeremy Ladd, another $5 super chat, mentioning the photos that he was able to snag from his roof vantage point, saying he sent them to myself, Adam, and Michael, go ahead and pop over to X in just a little bit, see if I can see those, or maybe one of the guys out in the field can take a look at that. Also want to thank one of our wonderful channel members, Michael McGrory, excuse me, for a $12 super chat. Thank you so much, Michael, with a very sweet comment saying, "You guys are needed. This is important coverage," and agreed, which is why we are more than happy to be with you in the now early hours of Thursday morning. Very happy to have your support. Another great way to support what we do, quick and easy for the 2,500 of you that are watching live and may not have done so, just by hitting the like button and sharing the stream. Help more people find this live coverage as we are now through the point which we'll have made the call on the started propellant load. Let's see if we can get an update on that.
Falcon 9 tanks are venting for the start of prop load. Attention launch operators, this is the launch director with abort instructions. For non-urgent no-go conditions, brief the CE or LD and they will approve aborting the countdown. For urgent issues affecting the safety of the operation, operators shall call hold, hold, hold on the countdown net. Launch control will abort the launch auto sequence immediately and proceed into the launch abort auto sequence. At T-minus 10 seconds, launch control will be hands-off and relying on automated abort criteria for the remainder of the count.
Our T-minus 36 minutes, 3 seconds and counting. We're now getting the mission audio from SpaceX and NASA supporting. So now that we have that piping in, as those callouts are made outside of the final countdown, as they come about, I'll go ahead and pause commentary so that we hear any relevant updates. Don't want to be talking at the same time as everyone. T-minus 35 minutes, 34 seconds and counting. Less than 30 seconds away from the start of propellant load. So before we go ahead back in to talk more about pace, let's go ahead and listen in, as we should be hearing the call out for the start of fueling in now less than 20 seconds, give or take a second or two.
Launch auto sequence has started.
T-minus 34 minutes, 51 seconds and counting. SpaceX has confirmed that propellant load of the Falcon 9 supporting the PACE mission is now underway. So after facing some literal and proverbial headwinds with the weather situation earlier this week, SpaceX now pressing forward towards the launch of this important mission for NASA. We're now T-minus 32 minutes, 32 seconds and counting. Of course, NASA's PACE mission is an acronym. PACE stands for Plankton, Aerosol, Cloud, Ocean Ecosystem. The E coming from ecosystem there. We talked about the color that's going to be observed by the ocean color instrument. And the thing giving off that color are microscopic organisms called plankton, hence the very important P at the start of it. And the man who's been studying plankton or phytoplankton for quite some time knows a lot about them and the impact not only on our planet but also on our lives as individuals is the project scientist for this mission, Jeremy Wardell. So let's go ahead and hear him from part of a discussion earlier on the importance of why the PACE spacecraft studying phytoplankton is so important to all of us.
What are phytoplankton and why do you care? Well, they operate just like land plants. Through photosynthesis, they convert carbon dioxide into cellular material, so form the base of the food chain while producing oxygen. They come in all different shapes and sizes. They taste different, so the fish tell me. They sink at different rates. Some get recycled in the upper ocean. Some can get to higher trophic levels or get eaten. Fecal pellets, poop, sinks to the deep ocean, and then carbon dioxide is removed from the system. So the community is really, really important because they all play different roles in the ecosystem. You have those that are beneficial, and as Karen alluded to, you have those that are harmful. And this gets back to the scales that we care about. Climate. Carbon moves through the system through phytoplankton. That's incredibly important. Shorter term, fisheries. Fisheries rely on the base of the food chain, thus phytoplankton. Switching over to economy, fisheries obviously, but also these harmful ones that contaminate drinking water, closed beaches, closed shell fisheries. You know, I think some order of 60% of the world or 50% of the world lives within 60 miles of the ocean. So you don't see it every day, but it does touch your life. So if you're a citizen of the world who likes breathing and you like eating and you like going to the beach, say thank you to a phytoplankton next time you see one of them.
Some wise words to live by as we are now T-minus 29 minutes, 58 seconds and counting to the launch of the PACE spacecraft, headlined by the P for phytoplankton. At this point in the count, they're loading cryogenic helium on board the Falcon 9 first stage. The helium is used to pressurize the main propellant tanks during flight. In about 5 minutes, that same cryogenic helium will be loaded onto the storage tanks of the second stage as well. Taking a look at the Falcon 9 vehicle from the vantage point of our friend Chuck Briggs, part of our team helping to track this Falcon 9 vehicle when it leaves the pad. Nominally, that'll be coming up at 1:33 a.m. Eastern Standard Time, 0633 UTC. We're now T-minus 26 minutes, 8 seconds and counting to the planned liftoff of the Falcon 9 rocket supporting NASA's PACE mission. They're getting ready to load that cryogenic helium on board the second stage of the vehicle. This particular Falcon 9 first stage, I want to go back to that, flying for its 4th time on this particular mission. It's got the tail number B1081 in the SpaceX fleet, so let's go ahead and talk about its brief but impactful flight history to date. And just to couch the dates that you see, these are based off of the launch in the context of Universal Coordinated Time, or UTC, liftoff. So the first flight for this booster came back on August 26, 2023, supported the launch of 4 of the crew that make up Expedition 70 currently on the space station. This was the Crew 7 mission to the ISS, commanded by NASA astronaut Jasmine Mugbelli. It featured the first commercial crew launch where all 4 members were representing different countries. Second launch was also a Dragon spacecraft, this time of the cargo variety. It was back on December 19th. Excuse me, that was back on November 10th. Also heading up to the space station. I'm jumping ahead of myself a little bit. The third and final most recent launch was on December 19th. That was the launch of the Starlink 6-34 mission. Now, among these launches, counting the one coming up tonight, 3 of them will feature return to landing site landings. If successful and B1081 is able to stick the landing over at LZ1, it will place it in a 3-way tie for second place as far as the number of land landings for currently active Falcon 9 boosters. The others that can boast that statistic are B1061 and B1063. As you can see on your screen, that stat even more impressive given the fact that 1081 has only flown 3 times to date, going for its 4th flight, and those other 2 boosters have flown 18 and 16 times respectively. And if you're a numbers person wanting to know which booster has the most land landings right now that is still active in the fleet, that would be booster B1071, which currently has 6. It's actually set to launch again as early as tomorrow night on the Starlink 7-13 mission. However, that is a Starlink launch, which means it will feature a drone ship landing. So, not going to bump up to 7 land landings for B1071 just yet, but you know that's coming in the near future, potentially. So we'll keep an eye for whenever SpaceX is able to make a return to landing site landing with a Starlink mission, if that is something that they are working towards, in fact. We're now T-minus 22 minutes, 50 seconds and counting. About 2 minutes away from the start of the big vent, the process of chilling down the feed lines as they prepare for a LOX load on the Falcon 9 upper stage. Appreciate the more than 3,400 of you that are watching live. If you haven't already, you could do us a big favor and help this coverage reach more folks as we're coming up on the last 22 minutes before liftoff, just by hitting the like button, sharing the stream. Also, if you're not already subscribed to Spaceflight now is a great time to do so. Once you do, be sure to click the bell icon. And that way you get notified whenever these live streams start, and you don't miss any of the videos that we post as well. Lots of coverage coming up for the rest of February, including the launch of the Intuitive Machines IM-1 mission to the moon, launch of a brand new quartet of astronauts to the space station with the Crew 8 mission. And we've also got the newest class of NASA astronauts getting ready to graduate. So February is a very exciting time on the Space Beat. Got lots to bring you. So you want to make sure that you're subscribed to Spaceflight now to get all the latest. Now T-minus 21 minutes, 23 seconds and counting to the planned liftoff of NASA's PACE spacecraft. Getting ready to study our little blue marble, focusing on the oceans and the atmosphere.
Stage 1, Pogo. Stage 2, RP1 load complete.
And as we see the start of the big vent here, also get the call out that the second stage rocket grade kerosene is now fully loaded. Another good call out, another milestone notched off as we continue our progress towards the launch of this Falcon 9 rocket. Now T-minus 17 minutes, 7 seconds and counting. Coming up on the end of the big vent here. As that begins to taper off, we're now less than a minute away from second stage LOX load beginning. This is the final fueling step that has yet to start. We should be hearing a call out for the beginning of that in about 40-ish seconds.
Stage 2 LOX load has started.
As the big vent wrapping up there, we did hear the call out for stage 2 LOX loading, now in progress. Just taking a look at the live chat, seeing some of the chatter in there. Sounds like it's a bit of a chilly night by Florida standards. Our Michael Kane chiming in saying, can't feel my hands and it is so cold. Well, hopefully we've got some hand warmers out there, Michael. I know Adam was bundled up. I want to thank our friend Chuck Briggs for this great view of the Falcon 9 here. Now T-minus 15 minutes, 17 seconds from the planned liftoff. Chuck, Adam, and Pete Carsons will be tracking the rocket once it leaves the ground here. I also want to take a moment to thank our wonderful moderators in the live chat. I see Stephanie B. joining us in there from Australia. So, g'day, Stephanie. Glad to have you with us. And Janine, who has been a channel member for 3 months. With a brief but concise yippee. Now, the PACE mission, as we've been talking about this evening, is designed to study both the oceans and the atmosphere. Important part of NASA's ongoing contribution to research about various aspects of our planet that impact and are affected by climate change. So heading into the launch attempt this week, we spoke with Karen St. Germain about the impact of PACE once it's on orbit. She's the director of NASA's Earth Science Division. We asked about how the data that's going to be gathered by PACE sent back down to us here on Earth will work in tandem with the other Earth-observing spacecraft like SWOT, which stands for Surface, Water, and Ocean Topography. That spacecraft launched back in 2022. Here's Karen St. Germain on what PACE means for all of us.
The experience of looking at PACE data for the first time is going to be something like putting on glasses for the first time and seeing with clarity. Maybe even going from color blindness to full color spectrum, right? So we'll see the biology of the oceans at this level of precision for the first time. Those nutrients, those plants in the oceans, they get moved around by currents. And that's really where the connection between SWOT, which is going to give us that physical view, and PACE, which is going to give us that biological view, that's really where that becomes powerful. Not only what's there, but how is it moving, where's it going, and why is it there?
Our thanks to Karen St. Germain for her time and talking with us about PACE. We're going to dip back into our conversation one more time as we enter into the final minutes of the count here. We're now T-minus 12 minutes, 13 seconds and counting. Coming up, the next milestone here for readiness of the Falcon 9 rocket will be the chill down of the 9 Merlin 1D engines at the base of the vehicle. It involves flowing a small amount of liquid oxygen through the plumbing and the turbo pumps, which will help protect them from the risk of thermal shock and damage during the startup sequence. Yeah, we can bang that out real quick. Apologies for the crosstalk. The user error hitting the wrong button. just talking about going back to the trajectory, since we've gotten quite a number of questions about it, and it's a bit rare. This will be SpaceX's 12th southern or polar trajectory launch from Florida's Space Coast. So let's go back and review that one more time before we come to the liftoff of the Falcon 9 rocket. As mentioned, the Falcon 9 will be flying in a southerly trajectory, heading toward the Caribbean.
Spacecraft is on internal power.
Hear that call out from SpaceX, another good milestone there. Falcon 9 will curve around Florida and it will fly over Cuba. Before that, though, the payload fairings will splash down a little bit north of Cuba there, as you see on the trajectory map provided by Adam and Steven. The recovery vessel Bob is going to be scooping those up out of the Atlantic and bring them back to Port Canaveral, where they will be turned around and refurbished for future flights. And this will be a return to landing site mission. Which means that once the rocket launches from Slick 40 over at Cape Canaveral Space Force Station, booster will perform a flip maneuver and head back to landing zone 1 for a land landing. So if you are on Florida's Space Coast or have some friends or family that are here, you might want to give them a heads up that they will likely hear a sonic boom as the booster is coming back in for an LZ-1 RTLS return to landing site operation. We're now T-minus 9 minutes and counting to the planned liftoff of the Falcon 9 rocket, getting right down to it, less than 2 minutes until the engine chill down sequence. As we're coming into this final minutes, appreciate the more than 5,400 of you that are watching with us live. If you haven't already, be sure to hit the like button to allow more folks to find our coverage as we get into these final minutes of the count. Also want to thank one of our wonderful channel members, Nelson Reyes, for a very generous $20 super chat. Thank you, Nelson, for that and for your ongoing support with channel membership. Who says, thanks again, Spaceflight Now, for the remarkable launch coverage. We are more than happy to do it for you and really appreciate you helping support us, Nelson. Thanks for being with us this evening.
Engine chill has started.
Now T-minus 6 minutes, 49 seconds and counting. Heard that call out for engine chill. Things continuing to progress nominally towards the planned launch of the Falcon 9, supporting NASA's PACE mission.
Stage 1 RP1 load is complete.
Hear that call out that RP-1 load, or the rocket grade kerosene, is now fully loaded on board the Falcon 9 first stage. So we're coming up on the final 6 minutes of the count.
Falcon 9 tanks are pressurizing for strong back retract.
As you hear that call out, SpaceX is getting ready to open up those clamp arms underneath the payload fairings and bring the strong back about 1.5 degrees away from the Falcon 9 rocket, where it will stay in that position until liftoff, when it will pull back in a much more rapid fashion. We're now 4 minutes 30 seconds away from planned liftoff.
Strong back retract has started.
You hear that call out? We'll see the clamp arms underneath the payload fairings open up momentarily now. We are now T-minus 4 minutes and counting. As we come into the final minutes here, I want to thank a few more folks for your support. Really appreciate it. Thanks to RPM for Years for a $2 super chat saying, "Go Falcon, go." $2 super chat from Janine. Thank you so much, Janine. Really appreciate that.
LD, this is MLM on Countdown Net. LD. Pace is go for launch. Copy.
And we hear that great call out that the PACE spacecraft is primed and ready for launch tonight, as we are now less than 3.5 minutes away from the planned liftoff of the Falcon 9 vehicle supporting it. Of course, we'll get the call out that the Falcon 9 is go for launch from the launch director, Tim Dunn. That's coming up T-minus 45 seconds. I want to quickly give a thank you to Kenny Gurley for a very generous $10 super chat. So we're now less than 3 minutes away from the planned liftoff of the Falcon 9 rocket supporting NASA's PACE mission.
Stage 1 LOX load is complete.
As we hear the call that Stage 1 LOX loading is wrapped up, the final milestone now is for Stage 2 LOX load to be complete. Closing in on a fully fueled Falcon 9 getting ready to launch. This will be the 8th time SpaceX has supported a mission for NASA's Launch Services Program, LSP, based here at NASA's Kennedy Space Center. This will also be the 12th polar orbit launch for SpaceX from the Cape. Two minutes to flight.
Stage 2 LOX load is complete.
And we now have a fully fueled Falcon 9 rocket as we come into the last minute 30 of the count.
Ground gas closeouts.
And that venting you're seeing is the ground gas closeouts as they're clearing the fuel lines, getting ready to send this rocket on its way, send this PACE spacecraft to a sun-synchronous polar orbit. Now coming up on the final minute. T-minus 1 minute to
Falcon
liftoff.
9 is in startup.
Coming up on Tim Dunn's call for go for launch in about 5 seconds.
SpaceX Launch Director, go for launch.
Here we hear that call out that we are go for launch for Falcon 9. This will be the 11th flight for SpaceX this year. We're now less than 30 seconds away from the planned liftoff of the vehicle. 20 seconds. 15 seconds. And here we go. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Engine ignition and liftoff of the Falcon 9 rocket, supporting NASA's space mission, getting ready to explore and study the oceans and the atmosphere above. The Falcon 9 rocket has cleared the tower. Now coming up on 30 seconds into flight, let's listen to the roar of those 9 Merlin 1D engines. Now 50 seconds into flight. Tracking team working hard to keep the Falcon 9 in frame. This view from Chuck Briggs as the vehicle climbs through some clouds. Falcon 9 now traveling faster than the speed of sound. It passes through 1 minute into flight. And max Q, the point of greatest aerodynamic pressure on the vehicle. Now coming up on a minute 30 into flight.
MVAC engine chill has started.
That call out to thermally condition the Merlin vacuum engine to support its burn. And some great tracking views from our friend Pete Carstens with Max Q Productions. See, this curve here is the dogleg maneuver, as we previously mentioned, for this polar orbit launch. Now a little over 2 minutes into flight. Coming up on the next milestone at T plus 2 minutes 19 seconds will be MECO, main engine cutoff, followed by stage separation, and then the second stage engine start. The boost back burn will begin shortly thereafter. You see MECO,
MECO,
stage separation.
stage separation confirmed.
And you see the ignition of that Merlin engine.
Back ignition.
Oh wow, and you can see the glint of the
Stage 1 boost back startup.
booster. Just some great tracking shots this here from our friend Pete Carstens. We were seeing onboard views from the Falcon 9 vehicle a moment ago.
Vehicle's on a nominal trajectory.
Some great views from our tracking team here around Central Florida. Now 3 minutes into flight. Falcon 9 first stage still in the midst of the boost back burn. That burn will end right about now.
Stage 1 boost back shutdown.
Near that call out for the shutdown, we saw the engine complete that firing. And we're getting some onboard views from the Falcon 9 second stage, that Merlin vacuum engine continuing its burn, powering the upper stage of the Falcon 9 vehicle with the PACE spacecraft on the other end, of course. Coming up on fairing deployment in about 10 seconds. Falcon 9 second stage making its way for a flyover of Cuba.
Pairing separation confirmed.
And we see those fairings falling away. The PACE spacecraft now exposed to the vacuum of space for the very first time. At a little over 4 minutes into flight, you can see we have our booster countdown clock also in motion. Just a little over 3 minutes until that first stage booster makes its touchdown back at landing zone 1 here at the Cape. We have our cameras trained and watching for it. That first stage entry burn set to begin at T plus 5 minutes and 51 seconds, just a little over a minute from now. Appear to have a nominal burn on the Falcon 9 second stage as the first stage continues to make its way back down towards the Cape. Now a little over 5 minutes into flight.
Nominal trajectory.
With a call from SpaceX that both stages are following a nominal trajectory. Some great views from on board the Falcon 9 first stage here. Coming up on the entry burn, now less than 10 seconds away. You see the lights of Florida's Space Coast as the booster comes back down.
Stage 1 entry burn startup.
The call for the start of that entry burn and some brilliant views from Pete Karstens. Seeing that booster coming back. Now a little over 6 minutes into flight.
Stage 2 FTS is saved.
Stage 1 entry burn shut down.
And that's the end of the entry
Stage 1
burn.
FTS is saved.
That call out the flight termination system has saved. No longer needed as the SpaceX first stage booster making its way back down towards landing zone 1. That landing coming up in less than a minute now. You see the countdown on the top right hand corner of your screen. Don't go anywhere. We are about 45 seconds away from that first stage booster landing. Landing burn starting in just seconds.
Stage 1 transonic. Stage 1 landing burn.
Hear the call for the start of the landing burn. And our Adam Bernstein's got it on the tracker. Well done, Adam.
Landing leg deploy. Stage 1 landing confirmed.
And we hear the call outs. We see the video. The first stage booster, tail number B1081, is 4 times up, 4 times down. And now we move on to the second part of the mission as we're hearing that sonic boom here at the press site. Now 8 minutes into flight. Coming up in just a little over 2 minutes from now, T plus 10 minutes and 20 seconds, we'll have the second stage engine cutoff, SECO 1. We'll end the first and only burn that's happening on the Falcon 9 second stage prior to the PACE spacecraft separating, heading off into its sun-synchronous polar orbit. Coming up on 9 minutes into flight. less than a minute and a half away from SECO 1. Following that, the Falcon 9 second stage will coast for just a couple of minutes before the PACE spacecraft deploys. All in all, this is a fairly short mission for SpaceX. Part of why they were able to perform. And we're hearing from our friend Pete Carsons with Max Key Productions. Saw some great views from him that car alarms were set off all the way down in Vieira, which, for those not familiar with the geography of the Florida Space Coast, is about 40 or so minutes south of where we are if you take 95 all the way down. So quite a ways to be setting off car alarms, which is not terribly surprising since this was a southern trajectory launch. So heading down along the path towards the Vieira area, but still quite a reverberation for that sonic boom. Coming up on SECO 1 momentarily.
MVAC shut down.
And you heard that call out? You see the glow of that Merlin vacuum engine starting to diminish as the shutdown sequence gets underway. Coming up on PACE spacecraft separation in just a little less than 2 minutes now. Now T plus 11 minutes, 25 seconds and counting. Less than a minute away from spacecraft deployment. There you see the PACE spacecraft getting ready to separate from the Falcon 9 upper stage. It's coming up in about 20 seconds from now. Should be seeing spacecraft separation any moment now. And there we go.
Payload separation confirmed.
And with that, PACE is on its way. You see there at the top right-hand corner of PACE, the solar panels, those developed by Rocket Lab. Those are set to deploy fairly soon following separation here. PACE will start drawing power to boot up all its systems. It'll spend the next few weeks here getting everything configured. It'll start sending back images fairly soon thereafter. Once it gets everything configured over about 60 or so days, then it'll really start being able to send back good high-resolution data and imagery. As we were discussing earlier, all the information that we're hoping to learn about the phytoplankton, their movement and their impact to all of us around the world. Just one piece of what the PACE spacecraft is designed to do. Now a little over 14 minutes into flight. You can barely see the PACE spacecraft anymore as we're now pivoting to inside launch control for NASA here. Taking a look at the NASA team that helped support this mission for the Launch Services Program. This is Hangar AE over on Cape Canaveral Space Force Station. Of course, the SpaceX side of the equation is over at Hangar X at NASA's Kennedy Space Center. This is the LSP specific room here that you're taking a look at. That is the logo of the Launch Services Program that you see there on the back wall as teams are awaiting confirmation of the solar array deployment, which it appears that they have just received. Certainly good news for the PACE spacecraft here. Once the spacecraft is on orbit, this is what it will look like once the solar array is deployed. PACE has a nominal mission life of 3 years, although it has enough fuel on board to last up to 10 years. In every 3 years or so, they will go back through and review the health of the spacecraft and determine if they are in a position to extend its life for another 3 years beyond that. So PACE could have a long history as part of NASA's Earth observing satellites. You see the strong back the strong back is coming up right there at pad 40, part of SpaceX's process of turning around the pad as quickly as possible to support its rapidly increasing launch cadence. Next mission we're expecting to see from this particular pad is another Starlink launch, the Starlink 6-39 mission. Now T plus 18 minutes, 13 seconds and counting into this mission. The teams at NASA LSP are awaiting to confirm that the spacecraft is power positive, that the solar array has deployed as intended, and the PACE spacecraft is drawing power and can begin to boot up its systems and start the configuration process. As we await for that confirmation, we're going to go ahead and stay with you until we get that. Do want to talk about another facet of this whole process, which we mentioned that PACE is a part of an ongoing line of Earth observing spacecraft, and so unsurprisingly, NASA is also looking towards what is on the horizon, bringing more online to help gather details and data about our Earth. And so we want to go back to part of our conversation with Karen St. Germain from NASA's Earth Science Division, who has a little bit of an explainer on what's coming up now that PACE has launched.
The very next one that we're working on is called Glimmer, and it will be a similar kind of capability, but it will be in geostationary orbit. That means it'll essentially be dwelling overhead, really focusing on the Gulf, the Florida coastline, and the Amazon river drainage. So the algorithms, the science that we develop under PACE is already being transformed into science and algorithms and data products that will come along with Glimmer. That'll be a few years from now. Looking a few years beyond that, we are just starting now to build a couple of really important missions. One will be, they're both part of the Earth System Observatory. One of them is called the Surface Biology and Geology mission. That is going to be the next generation. So it will stand on the shoulders of PACE in terms of really understanding global biology. And we didn't talk about geology here, but understanding mineral composition can be done with the same technology. So that's that mission. A second Earth System Observatory mission is the Atmosphere Observing System. That really will focus on these questions of clouds and aerosols and those interactions. So yeah, a number of missions coming up that are anxiously watching PACE, and PACE will inform how we build those missions, how we do the science, and how we deliver applications.
I want to once again thank Karen St. Germain, the director of NASA's Earth Science Division, for spending some time with us ahead of the launch, giving us a glimpse into what PACE has on tap for it, as well as what's coming up next down the line. Still awaiting confirmation that PACE is power positive, so while we are waiting for that, want to thank a few more folks for their support of our live coverage this evening. Some of these coming in before, during, in the midst of the launch, so forgive the timing of this, but do, of course, want to acknowledge all these wonderful folks for their support and helping us do what we do here at Spaceflight Now. Our channel member Josh King with another $10 super chat. Thank you for that, Josh, saying, go Falcon 9, go PACE. Yes, indeed, and it is on its way. Alina Hawk with a very generous $20 super chat. Thank you so much, Alina. Says, peace and love to everyone from the Olympic Peninsula in Washington State. And hello, and our best and warmest regards to everyone there in Washington. Want to welcome Susan Enderl. Apologies, Susan, if I mispronounced your last name, but welcome aboard to channel membership. Includes, of course, a number of perks, including being able to watch all of our CAPE launches in 4K, discounts at our online shop, shop.spaceflightnow.com, as well as access to member-only videos here on YouTube. And our channel member, Norman Reitzel, with another $2 super chat. Thanks for that, Norman. Ask as much as possible to please include telemetry. And, of course, we certainly try to. We want to make sure that we bring in the trajectory map in the run-up to the PACE mission and all the launch as much as possible. We're a little bit at SpaceX's discretion when their telemetry data and map gets brought up. Perhaps we can work on a way to try to keep something more continuously in our stream. We can talk about that offline and see if that may be a possibility. I don't know, something to troubleshoot if we might be able to work that out. Thank you for the suggestion. Thank you for the support. Taking a look back now inside Hangar AE, NASA's launch team. Again, continue to track the progress of the PACE spacecraft as we are waiting confirmation that PACE is power positive, the last milestone here in the progress of this mission so far. Now T plus 24 minutes, 9 seconds into the count. Things seem to go well for SpaceX on this whole venture. You see there An empty pad, the transporter erector brought back upright. And a glowing crew access tower, which we expect may come into play later this year, although SpaceX has not said specifically for what mission they may use this for. There are a few more crew flights coming up on SpaceX's docket left in 2024. Of course, there's the launch of the Crew 9 astronauts later this year, no earlier than August. Did have that crew announcement that was made recently. Want to go ahead and bring in another voice. This is NASA's Daryl Nail providing some updates on where things stand with the PACE spacecraft. Let's listen in for a moment.
And separated from that stage 2. It was in the midst of an eclipse, so it was a quick goodbye. We saw it go off into the darkness of space.
Yeah, I'll tell you, the pictures from stage 2 were incredible. Not only watching PACE separate from stage 2, but just continuing on its way to perform this exciting mission that we've heard all about this morning. But that video, just, you know, it was exciting to watch that and be a part of this. And I know the PACE team is anxiously awaiting that power positive information. But you know, we got PACE where it needs to be and on its way. So this is a great start to the launch this morning.
Jim Free, NASA's Associate Administrator, is here on hand. He is there in the control room. You can see him in the second row in the middle, the fourth from the right. All along the first row, the teams from the Goddard Space Flight Center. They have a team back at Goddard that is online as well, the Mission Operations Center, and that's where the spacecraft will be commissioned. And it is also where they are sending commands and receiving telemetry at this very moment.
Goddard Space Flight Center, also the location where the PACE spacecraft was built. And they contributed the ocean color instrument, the primary instrument for the PACE spacecraft. T plus 27 minutes, 42 seconds.
I spoke to PACE Test Director Nusha Hagani, and she relayed to me that this is these are some tense moments. You know, as a team watches and waits to get that confirmation that the sun is shining on the solar arrays and it's oriented in the correct direction. Once they get that confirmation, I'm sure we'll see a reaction from the team.
For the spacecraft development and to cover the costs of...
According to the milestones, we are at the point in which the Goddard spaceflight team can command the spacecraft after waiting for a period of time as it came off of the second stage. That's so they don't get anything mixed up with the second stage of the rocket as it's going into a disposal burn and the spacecraft is going on into its orbit. T plus 29 minutes and counting.
PACE
we
mission.
are now into the moment where we would expect the milestone of power positive to happen, but we also know and have been told by the Goddard team that it could take a little longer.
Yeah, Daryl, I know as the spacecraft team is waiting for this information, the launch vehicle team has been doing a quick look on how Stage 1 and Stage 2 performed today, and so far everything is reporting in as perfectly performed launch vehicle today. As we saw in the video spacecraft step, Falcon 9 delivered pace where it needed to be. So that's good news on the quick look of the launch vehicle. And I know that the PACE team is excited to be where they are, just waiting for that power positive confirmation.
Great report out there, Mick. And as PACE was delivered to an orbit 674 kilometers, about 400 miles above the Earth's surface.
Those
PACE has 10 years of fuel on board to do its observations and report back its scientific data. But you never know with these satellites. They can go a lot longer. Just depends on how they use their fuel.
The lights that you're seeing here at the bottom of the screen near the transporter erector, just want to make a note of that. We've got some crews out there at the pad already surveying things, giving the pad a checkout. We're still waiting confirmation that the vehicle, the spacecraft's PACE, is power positive. As you've heard from NASA's Daryl Nail, the row folks at the bottom of your screen, closest to the left, are from NASA's Goddard Space Flight Center, the team that will be managing this mission, also the team that built the spacecraft. At this point, they should have received confirmation that the spacecraft is power positive, but as Daryl has noted, that process could take slightly longer than what was estimated. We're now T plus 33 minutes, 10 seconds and counting. These are the solar arrays in question that were contributed by Rocket Lab. These are ZRJ solar cells, part of the commercial contribution of this mission. Rocket Lab describes these as ZRJ radiation hard solar cells.
All right, you can see the applause there in the Mission Director Center. The spacecraft team happy to report that they have power positive on the PACE spacecraft. Again, the final milestone, power positive on the solar arrays on the PACE spacecraft. That's great news. Congratulations to the PACE team.
Absolutely.
This is a big moment.
Successful mission.
And there here, the call out that we've been waiting for, that the spacecraft is power positive, the last big thing that they were awaiting. Then now the spacecraft is able to drop power and start getting on its way with its primary mission. Now NASA Goddard Space Flight Center can claim mission success up to this point. You can see some very relieved faces in the room. As we were mentioning, these solar cells were contributed by Rocket Lab. They're important because we'll actually see them fly in another piece of crucial NASA architecture, as they'll be contributed on the power and propulsion element of the forthcoming Gateway Lunar Space Station, a key element of the Artemis architecture, helping NASA get humans back to the moon in a sustainable way. Taking a look back one more time inside the control room here at Hangar AE. One other commercial contribution to this mission, want to note here. These Course Sun sensors, 13 of these contributed by Redwire Space, headquartered just up I-95 in Jacksonville, Florida. These sensors, along with the spacecraft's star tracker, work in tandem as part of PACE's attitude control system, helping to keep the PACE spacecraft in the right orientation as it conducts its important science observation. Redwire has similar sensors on the Psyche spacecraft, as well as the New Horizons mission and the Parker Solar Probe. So, very important component of the spacecraft in use here. Before we go ahead and close things out, want to welcome Michelle Potter to channel membership at the pad leader level. Welcome, Michelle. Glad to have you with us, and thank you for your support. We're working on bringing in some of our photos from our launch team that were out tracking the mission tonight. I want to share some of the launch photography from our Michael Kane here. Got this great picture from liftoff as the Falcon 9 rocket was climbing up through the clouds. You can see a little bit of what appears to be a little cone as the vehicle was going faster than the speed of sound. This great nebula here as stage separation. Oh, I mean to pass by that as quickly as I did. There we go. Go ahead and linger on that for a moment as we're T plus 38 minutes, coming up on T plus 39 minutes into the count. Despite some challenges with the clouds, got a nice streak shot. Again, this is a becoming a more common occurrence, but still fairly rare to see a polar orbit launch, which gives a unique opportunity for the a nice streak shot as the booster is coming back for a landing down at landing zone 1. We'll have some launch photos from our Adam Bernstein as well. And we've got some launch photos from our Adam Bernstein to share as well. This photo from just a moment after liftoff there as the Falcon 9 had climbed past the crew support tower there at pad 40. And his own streak shot of the polar orbit launch from his vantage point here at the press site at NASA's Kennedy Space Center. And while the clouds were not an impediment to the launch itself, it did provide a bit of an obstacle from a launch photography perspective. Our team has made the best of it, as well as anyone possibly could. So appreciate the fellows for hustling hard out there and getting some great photos, as well as to our friends Pete Carsons with Max Q Productions and Chuck Briggs for providing some excellent tracking views of the Falcon 9 rocket. And as you see things starting to close up as folks are packing up, getting ready to leave here from Hangar AE, let's go ahead and do our finale for launch coverage, as we always do, and step through the mission stats now that we have a successful launch, landing, and the spacecraft, the PACE spacecraft, now on its way to conduct its science observations. This was the 4th flight of Falcon 9 booster, tail number 1081. This was SpaceX's 296th Falcon 9 launch to date. This is the 11th Falcon 9 launch of 2024. The 241st Falcon booster reflight, or the launch of a booster that has flown at least once. This was SpaceX's 11th orbital launch of 2024. The 98th orbital launch for SpaceX in the last 365 days. This was the 167th SpaceX orbital launch from Pad 40 and the 222nd overall launch from this particular pad. And just as a marker of how often SpaceX happens to launch from Pad 40, with this launch number 167, just for SpaceX launches that is, that ties the total number of launches from its other pad, Pad 39A here at NASA's Kennedy Space Center. Moving on, bringing in that bar chart again, we have launch number 11 for SpaceX on the year, working toward their stated goal of getting at least 144 orbital launches with its Falcon family of vehicles. Shifting now to the recovery stats, this was the 36th landing at Landing Zone 1, LZ1. When you combine it with LZ2, makes for the 45th SpaceX land landing in Florida. Put together with California, this is the 60th overall SpaceX land landing, and the 270th overall SpaceX booster landing to date. Rounding out with a global view here, this was the 8th orbital launch from Florida, the 12th orbital launch from U.S. soil, the 13th orbital launch from a U.S. rocket company, as we did have Rocket Lab with a successful Electron flight, getting ready for its second Electron launch later this month. And this was the 25th orbital launch globally. So how does that stack when you put in all the countries from around the world? Well, here's our pie chart. got this for you. Go ahead and clear the box with the tower. Thank you, Stephen. As you see, with the United States representing the lion's share of launches to date. Of the U.S. with 12, China has 8, Iran has 2, and both India and Japan each have 1 launch each under their belt. Japan getting ready, in fact, to have another test flight of its H-3 rocket coming up later this month. In fact, coming up on the 14th from the East Coast perspective, on the 15th local time in Japan. And as was just reminded in my ear, we don't have any Russian launches on the board yet, but that is going to change fairly soon, as there are a couple flights coming up from Roscosmos, including both a Progress vehicle, which is set to launch later this month, I believe, and a crewed Soyuz launch, including NASA astronaut Tracy Dyson, launching from the Baikonur Cosmodrome to the International Space Station. We traveled to Houston to talk with Tracy, as well as the astronauts and cosmonaut of the Crew 8 mission. Crew 8 set to launch later this month, so be sure to keep an eye out on the channel for those crew profile pieces to get to know both of those crews just a little bit more. And with that, we're going to go ahead and close things out. Want to thank just one more person, looks like, in the live chat. Heading out the door with a bit of generosity. I want to thank channel member Nelson Reyes for gift of 5 Spaceflight Now memberships. If you're one of those lucky ones who is now a Spaceflight Now channel member, be sure to thank Nelson on your way out if you haven't already in the live chat. Want to once again thank our friends Pete Karstens with Max Q Productions and Chuck Briggs for their help in tracking this Falcon 9 vehicle through some challenging clouds tonight. Do want to extend an apology. We weren't sure until just now that unfortunately a loud beep went out. The NASA feeds were cut without a heads up, so unfortunately we did not have a warning ahead of time. Otherwise we would have brought down the volume on that, or maybe blasting some folks' ears. So apologies for that. It was a bit out of our control, but just want to make that acknowledgement real quick. Also want to thank our ACE launch photography team out working hard tonight. You saw some of the launch photos, but if you're not already following them on X, and you are on X, you really ought to do so. They are Adam Bernstein at @BurnNYC and Michael Kane at MD Kane Jr. Of course, thanks to our editor, Stephen Young, for running the technical aspects of the broadcast tonight. And most importantly, thanks to all of you for spending part of your Wednesday evening into Thursday morning, wherever you are in the world, whatever time zone you're in. Really appreciate you spending part of your day with us as we covered NASA's PACE spacecraft heading on its way to a sun-synchronous polar orbit. For all of us here at Spaceflight Now, I'm Will Robinson Smith. Thanks again for your time and attention. Be sure to be good to yourself, be good to others, and we will see you next time. Good night.